You are in the SAS412. We are going to talk about cost-efficient multi-tenant knowledge bases. If this isn't the talk you want to be, you're not going to hurt our feelings. You're welcome to go and find one that's a better fit for you. But my name is Mike Gillespie. I've been with AWS a little over 9 years, and I really like these types of engagements where we're talking with our customers, learning about what problems they're facing. So as a code talk, this is going to be very interactive. These are very dull if you guys don't participate. So we're leaning on you, depending on you. I will, when the time comes, I will go around and bring a mic so everyone can hear your questions. There'll be times when you stump us. That's fine. You know, we don't know everything, but
that would never happen.
That would never happen. It's happened to me. It won't happen to you. That's what happened. Stephen, do you want to introduce yourself?
Hi, I'm Stephen Warwick, Solutions Architect at AWS for the last 5.5 years, but definitely a builder. I was an engineer before for 30 years or so, building various things and all across different industries. So enjoy very much the SaaS-based architectures, though, and been working with customers on that ever since I started at AWS. So that's what we're going to dive into today.
Yeah, and we both work with software companies. So we're familiar with the challenges that software companies face every day. And the origin of this came from something Stephen was working on. People came to him, asked him about how to build knowledge bases. He's like, well, happy to help you. And then it came into, well, we need to have different tenants and different...
We need to section things out. Imagine that. We
section them
out.
Not
have people look at the same stuff and get the same answers.
So we'll start off by talking about what are knowledge bases. I'm sure with AI, many of you are already familiar with that, but we want to set a baseline of what we're talking about today. And then some of the challenges that you face running RAG-type architectures with multi-tenancy. And we'll focus on a few of those. We have a demo, which will then go right into the code, and we'll show you, where in the code that these decisions are being made, where the logic's happening. And that's where you come in. That's where you can ask questions, see how we think through these things. And like I said at the beginning, I love these code talks and chalk talks because it gives you as a customer a window into how AWS thinks about these problems. We see these every day working with our customers on AWS, and we have a certain point of view, and this will help you see that and be able to translate that into something that you see every day. So go ahead.
I was going to say, there's not always one right answer either. Our answer is definitely one of the ways you can do it, but
yeah, for sure.
I think we've had lots of comments from even the sample code is out in the world too. So if that's one thing we want to get to is feedback from today.
Yeah, for sure.
What do you see out in the world and how are you using things?
Yeah, and that's part of what our point of view is. This is how we see things, but you may approach things differently because you have different problems to solve. So jumping right into it, what are some of the main design decisions that you have to face when you're building multi-tenant knowledge bases? One is data segmentation. You have tenant-specific search. You'll have one tenant that want to upload documents or other resources into your application, and then be able to have a chat against those or be able to search against those in a semantic way. But of course, the one thing you can't do, you have one job, and that is to not let the data spill over from one tenant to another. So what are the mechanisms that you can use to enforce that? You also have a hybrid search, so it's not just semantic search, but also keyword search. And then enabling that with AI. So how do you hook that up to a chatbot or be able to run AI-type queries against that within the scope of that tenant?
There's a little other paradigm that we're going to talk about today, too, is how to do that easily across different types of vector stores and things like that. We want to make sure that customer A might want super low latency, customer B, not so much. They just want to pay less and they want to have bulk stuff. But how do we do that in just an easy way across the board so that we don't have to do a lot of work to set that up?
Yeah, that way you don't have to write a whole new application for each way you access your data.
Yeah.
So I've talked about this already a little bit, but data isolation, that is like the core tenet of a multi-tenant application is how do you enforce data isolation? And the philosophy I have is don't leave that to chance. You have to build the infrastructure around it to enforce that happens. As Stephen called out, tiered performance. Not all of your customers are the same. You may have a free tier where you're just trying to get customers a sense for what your application can do, but you want to minimize the costs or really use a pay-for-what-you-use model versus established customers that really value the latency. Working with software companies that build chatbots, the number one complaint customers get is latency. I type in my question, and they have to wait 30 seconds for an answer. That's not acceptable. So how do you make your application be able to balance both the cost effectiveness, but also meet the latency requirements of your customers? And because the vector stores that power the knowledge bases are some of your pricier data stores, how do you make sure that you have the right data lifecycle management? And there's a couple reasons for this. One is certainly for cost, but also unstructured data tends to age very quickly. You may have an updated document that now reflects a new version of this data reality. How do you age those out in a way that makes sense for that particular tenant? Did I miss anything?
Yeah, just different industries, you'll see this a lot. So like the real estate industry, they might want to have like segments of their market set up, but that real estate cycle is changing quickly. Or patient records, if they're throwing it in a knowledge base, it's like the doctor might see someone every 6 months and they might want to throw that in and then take it out, maybe for regulatory things as well. They want to make sure it's only in there for a certain amount of time. But it also allows them to shrink the amount of usage that they have to use and only do it when they need to do it.
So looking at tiered performance, the underlying vector store that powers your database makes a big difference. Comparing 3 of these options, and there are many more, but looking at OpenSearch is a very popular vector store for the customers that I work with. It's very low latency, it allows you to do hybrid search, and you can have the provision cost to meet your demand. Compare that to PG Vector, which has the advantage of it's also low latency, but it's also integrated with your structured data. So if you have hybrid queries that query against structured data and your unstructured data, you can do that in one spot. And then last year at reInvent, we announced the S3 vector bucket, which allows you to run vector queries against data stored in S3. Really cool, because you only pay for what you use. You pay per query and for the data that's being stored. You don't have that provisioned cost that you would in OpenSearch. However, that does come at the cost of higher latency per query. So in the case that I mentioned before, where you have a free tier, you may want to have that on the vector bucket so that you're only paying for that evaluation use case that your customers are just kicking the tires, whereas your more established customers may want to have latency. But as Stephen mentioned, we don't want to write 3 different applications, more or less, to interface with our vector store. How do we abstract that out so that we get the simplicity of one way to access our data, but the flexibility to drive the back end how we want it? Another challenge with the lifecycle management. How do we define rules for data retention? How do we ensure that you're running against the most up-to-date and accurate information? I know working at Amazon, we have an internal wiki, which is usually out of date shortly after you publish to it, right?
Yeah, pretty much.
So how do we make sure that the data that's in there is actually up to date and age out the data appropriately? And the tenant tiering that we talk about is how do you have different rules based on the tenant? As Stephen mentioned, you may have a real estate with a very high churn rate of the data in your documents in your vector store versus ones that may have much longer, and be able to configure that per each tenant.
Yeah, it could be file sizes, it could be file types, that kind of stuff as well.
So given that challenge, so the architecture that we're demonstrating today, and again, as Stephen said, this is not the only way to do it, but we found this to be a very effective way to abstract out what that vector store is so that we can simplify our code, but also give that flexibility on the back end. So walking through it, you have the user interface. It's secured with Cognito. And that's important because that Cognito stores which tenant that user belongs to. So that will be part of the JOT token that gets sent through so that the back end can then make decisions based on which tenant they belong to. That gets sent to the Lambda function, which uses Bedrock to do the inference on the LLM, and then uses the Bedrock knowledge bases to interface with the vector store on the back end, whether it be in OpenSearch, S3, et cetera. Anything else?
Yeah, I think that's like one of the key things we're going to show is like how we're using the custom stores and the custom data types and stuff so that you can do this in other ways where you're storing your files in different areas of S3 or something like that, and you can use metadata files and things to pull it in, but it's an ingestion pattern that is kind of like a fire and do a batch pull in. So we're gonna dive into a little bit today of how you can do that in a little bit more bespoke manner, and we'll go through a little bit of the code of what that looks like and the main key points. We only have so much time, so we're not gonna go through all the code that's there, but we wanna make sure that you understand, hey, these are the points you need to make or to build into the system to derive like individual files that you can pull into these stores for tenants, for users, whatever way you want to break it down as well.
Great. So I'll switch over.
All right, and remember, this is interactive. If anybody's got questions and things, feel free. Let's see if it's coming up. So we're going to do a little bit of demo just to kind of show you and see what is possible. Again, this is just kind of a tech demo to show you what's out there. So the first screen that you're seeing here is tenant A. So I've logged in, and I've got a bunch of files in here that I've added. I'm trying to pre-populate this because we all know that the demo gods don't love us very much, and we want to make sure that it runs. So what you'll see here is I've got a few files in here for tenant A, which is an S3 vector store. You'll notice there's a few files that have been timed out, and then some other files have an expiration date. So those are the ones that I've gone in and said, this file particular to me, I want to go and add to the knowledge base. So it's going to say, you've got so much capacity. Again, when you're building these systems, it's probably baked in. You won't be showing these screens to the users and things like that. Of course, demo gods are going to hit me in the face for this one, but so imagine that gets ingested. So now I'm tenant A, I am a user in the system. I've got my indexed files in there, and then I can go and chat with those particular files. So I've already done a chat before because, of course, again, the demo gods. I'm only seeing and interacting with the files that I have ingested. And this could be per tenant based or per user based. So I've ingested these S3 files. And I asked some questions on it. Now I'm going to switch over quickly to tenant C, just to kind of show you, like, tenant C's on OpenSearch. They've got a lot more files they're allowed to ingest, a lot more file usage. They can do a higher query rate, things like that. And you'll see that I've indexed again, but they've got a way longer expiration period that they can have as well. So while they're going through, they can do another chat, and they're going to be chatting again against their own files per tenant, per user in this case. So when I go into a chat in here, you'll see that I've got my index files, and I can go and ask it a question like, what programming language? Let's see if we can actually get it, if I can spell. I can't spell at all.
It's like horseshoes, right? Just speak to us.
Let's see. Now, I think my network is failing like crazy in here, so we're going to pretend that came back. That's why I had the other chat pre-populated. So what we want to do, though, is just give you an overall view of like what's possible, right? So if you break it down, you can break these files down. But we want to get into some of what the code looks like and how we make this happen. So I'm going to switch over to our friendly neighborhood Kiro system over here.
I want to zoom in on that.
Yeah, we're going to.
Our friends in the back.
For the people with the eyesight that we were just talking about up here. We're getting to that. What prescription? I think I need a new one. Okay, so in here, this is my main stack. And what I'm doing is I'm creating a couple of the knowledge bases here. And you'll see that I've got ones where I might want to set it up or I might not. But I want to show you this because
just pausing one second. When you say main stack, what do you mean by that?
That's right. This is the CDK application that is going to build out the infrastructure inside of AWS for us. And this part of the stack is the primary stack that runs first and is building out. I'm calling out to a bunch of other things to build out the knowledge bases and do the connectivity between everything. So I want to call this one out because we're going to jump into this knowledge base class as well in a second here. But you'll notice that there's a couple of them. There is the OpenSearch one, and that there's a Postgres knowledge base one. Now, note that we said S3 vector as well. That the CDK constructs and CloudFormation constructs for S3 vector are still in the mix, I should say, or like kind of being churned on. So that is built off in a different stack because I have to use the APIs directly for those right now. So there's custom resources to build that out. But for the end result, you're still going through a knowledge base for the querying, which we'll get into in a second here. So I'm going to go over.
So the key takeaway there is that you're building the infrastructure to have the knowledge base, and it's connected to the backend vector store.
Yes, exactly. So this is that knowledge base stack that I was talking about. And I'm going to zoom in here. So we've got a bunch of stuff at the top that's setting up a few things, is sanitizing names, things like that. But one of the key things we want to do first is set up the knowledge base. And I'm just going to copy some things in here to save time of me typing because nobody wants to see me just type away. So we've got our knowledge base. We've got we're setting up the name and things like that. Now the next most important thing is the knowledge base configuration. So I'm going to copy that in here. And you'll see what I'm setting up as the vector type. You can set up these embedding models and things like that, whatever you want across. You could pass these in as variables again for the particular knowledge base that you're using. I've set them kind of across the board for the knowledge bases that I'm going to be setting up. And then we want to do the storage configuration. So in this instance, this is where I'm creating this knowledge base storage configuration, and I'm passing in my OpenSearch or my Aurora stuff. So if we jump into there, you'll see that for RDS, I'm setting it up a specific way. So I'm saying, I've got my embeddings and chunkings for RDS. And if it's Aurora, then we're going to be setting up a different way. And then for OpenSearch, we have to use I'm setting up with OpenSearch serverless. And again, I'm going into each individual one, and I'm setting up the individual vector stores. But once we get to the actual querying and things like that, I don't have to worry about that. I can just say, this is the one that I'm going to, and it's all each one is set up, and I can just point it to that, and it can go.
So that was a lot to cover.
Yeah.
Really want to open up to questions or comments, or was there points like why did you make that decision, or what, why did we do that? And if no one asks questions, then I'm going to ask questions, and I'm probably not going to ask the same question you are. So any questions, raise your hand, and I may have to step to the side to see.
And while he's going to find it, there's the next thing that we need to set up. We've got the knowledge base configuration, but we do need the data source, right? We need to tell it where the data is coming from. So I am going to set up a data source in my code. Unless there's a question over there,
one
Mike.
question is related to the different vector stores. What is the pros and cons for each one?
Sorry, I can't see.
Did you hear the question?
I did not.
The question was, what are the different pros and cons for the vector stores that you had set up?
So the pros and cons, I think Mike went over a little bit there, right? But it's typically what I've seen with customers is the price to latency ratios that they're seeing in there. So if it's a customer, like you might have a free tier, right, where you really don't want to spend a lot of money on that. That's just the kind of the way to pull the customer in to see what you're doing. So you might use an S3 vector store there because the latency on every question might be a little longer, depending. This is bang for your buck. You're gonna have to go in there a little bit yourself, depending on the file types you're using and things like that. So it's kind of on you to do a little bit of research to figure that out. But we have seen, also, if you're using Postgres already and you're using OpenSearch, you might just want to go those routes.
To add on to that, I mean, that's typically what I've seen is we are familiar with Postgres, we know how to run it, we know how to operate it, and we need a low latency vector store. It's a good fit. Versus OpenSearch, we have many customers that run OpenSearch for other purposes. It's just a natural fit to put their vector in Postgres. But there's many others. Pinecone would be an example. So there's probably a whole talk just on pick your vector store. But the point here is one size does not fit all. You'll likely want to have multiple options with different dimensions, and the extreme with latency being S3 versus OpenSearch or one other. Does that help? Or yeah, I'll be right back. Unless you can yell, and I'll repeat the question. I'll come back.
You can jump back there.
Go.
I was curious, so right now we have a knowledge base with fairly small tabular data that's loaded in S3 and using OpenSearch for that. I was wondering if for small tables it will be worth it moving to the Postgres vector since it's tabular data, and will there be any accuracy implications for the agent that uses that knowledge base?
That's going to be a tough question for me to answer. If you look, there are some samples out in the AWS samples GitHub repo that kind of they let you run your own kind of performance testing on this kind of stuff. What we found is it really depends on the type of data that you have and the size of data, and to your point of like how many columns there might be in there, different types of things that has to chunk out. And there's quite a vast difference between the embeddings that you're using, the chunking size that you're using. So it's really difficult without looking at your data and doing some performance testing first to really figure that out. That's why we kind of usually go back to the customer and say, like, let's do a couple demo runs of this and use some of the samples that we have out there on your data to figure that out.
And I'll stress that the embedding and the chunking have a much bigger impact on the quality of the search than necessarily what the engine running the math is.
Thank you.
All right, well, he's jumping to another question. I'm going to add in the data source here because I think this is one of the key things when you're creating the data source for the knowledge base. We're setting the data source configuration to be custom, and this is one of the key points in here, is this allows us to actually say, instead of going to the data, like to have an S3 and just pulling everything in when the files are there, we want to do this very bespoke and we want to do it custom. So we're setting it up to be exactly like that. And you'll see once we get into the ingest part, so I'm going to just copy the rest of this in here just so you see what it looks like. So I've set up my data source now. I've got the custom. And we're going through stages here, right? Set up the data source, set up the knowledge base. We're going to get into the ingest next and the query, and then what it looks like when we time out data and cleaning that up. But sorry, Mike, was there
Did you still have a question on that? Yeah.
If we need to inject the caching layer on the previous architecture, how it can fit?
Sorry, I didn't quite hear that.
How would we put a caching layer on top of that previous layer, on top of the vector store?
That's a very good question, not one that I've thought of. I mean, depends on if you're using like CloudFront as a fronting mechanism or something like that, you could try to do some caching of the results in there. I'm sure you could probably use Elasticache and some other tooling in there if you wanted, but I don't have a bespoke answer for that from here. And that caching wasn't part of this system per se. Oh, another question.
One more, then we'll move on.
What are some advantages you've seen to adding the knowledge base layer versus
going directly to individual? Actually, so we'll
cover that
stuff. Yeah, we're going to kind of go into that and kind of show why we might want to do this. Yep. So ingest and querying are part of those things. So I'm going to go to the ingest section here. So this is a Python file that's going to be doing my ingestion of my documents. So this is when I clicked a couple of those files and I said, hey, run the ingestion for just these files. They're sitting in S3. So my users uploaded them. I don't want them to be in my vector store at all times. I just want to do it at particular times. So you'll see in here that I'm running through the files and I'm going to set up a document structure. And this is one of the key things that we're going to go through here is we're going to set up a content type. And, oh, yeah. Hey, thanks from the audience. So we've got a document and we've got a content. And again, the data source type is custom. And we're giving it a file identifier and the location of the file, and we're saying it's S3. So we're setting it up saying we know where the file is. But next, we're going to add in some extra stuff, which is arguably the most important thing is the metadata for these files that we're passing in. So if you're doing this in a bespoke manner, you're going to have to do this for OpenSearch differently, for S3 vector, different Postgre, whichever, name your vector store, you're going to have to figure out how it's doing these filtering mechanisms and do it through those. So like, if you're using OpenSearch, you can also, on the query side, you're going to have to figure out how do I do that query, or if it's PG vector, I have to write the SQL query, right, to do this with the filtering in place. So I'm going to add this in here so we all know exactly what I'm talking about. So I'm adding in metadata. And again, you could do this with S3 if you want to do bulk ingestion. There is the ability to put metadata files in there. But what this is allowing me to do is to check those files and individually pull them in. And then also, what I'm doing here is setting the metadata, the user ID, and specifically the tenant ID, so that when I'm doing the querying, I can come back and do the exact same thing in reverse, I guess, is set the tenant and say, hey, I want to query for that tenant. There's one thing that I am not showing in here is I'm also adding these, I add them into the knowledge base, into the vector stores, but I'm also adding a record into a Dynamo database. And in that database, I'm setting a time to live, a TTL, which is, I think, arguably one of the most underrated things that people just don't use for some reason. It's awesome. You can do TTL or events and triggers from other systems in AWS, but the per record way of doing it in Dynamo, and it's, I arguably say, very cost effective to do this. That's what lets me set up that expiry date in the files that I showed in the demo, right? There's a, it's an 8-minute window or 8-day window or a day window, 24 hours, whatever it is. So I've now gone through the ingest. I've set up the metadata to be able to know that I can filter on those. And this metadata is in the vector stores, tied to the vector stores. This isn't in Dynamo. A lot of this record is
to add some color to that, I mean, the key is that regardless of what vector store you're using, it's using this structure, right?
Yes.
That way you don't have to know that it's a specific index in OpenSearch.
I don't have to duplicate this. This code is like one set of code, one set of queries that I have to do across the board for whatever vector stores that the Bedrock knowledge base supports.
So to answer the question that came up, like why wouldn't you just talk directly to vector stores? Well, this gives you an abstraction layer that allows you to work at the metadata level that would then push that into the vector store regardless of how that's being stored.
All right, so now we have
a question over here.
Oh, yeah.
I'm keeping an eye on time. We're plenty good on time, so.
I feel like I should be standing too, but then I'm typing really odd. And
my question would be like, how would the system react to nested metadata? So for example, let's say we have a book has like multiple authors, and authors would have like names, and these names could be like, in Japan, you would have like names in the Japanese characters.
Yeah.
In UK or US, it would be in English characters. So how would you design your metadata for Bedrock, or like, for more efficiently?
I'm not sure if that would, so I think I understand your question of like Unicode characters or other type of characters, if they're in there or not. In this form, I'm not sure if that would really come into play, because in this form, I'm saying a tenant ID, and I'm filtering by a tenant and a user, not specifically the content. The content gets ingested as whatever vector store is ingesting. So it's using that embedding model to break it apart. So I think it would, the question would be going back to that embedding model and making sure that it supports that. In this case,
in this schema, can you have a list be, or an object type as part of the schema?
I'm not sure. I'd have to go back and answer that.
We'll have to research that. I think that's how I would start looking for it, but I don't have the answer off the top of my head.
There's not a definitive. There is in the querying side, you can do and all kind of things, right? So we're going to get into that a little bit in the next step. Inserting the metadata is an individual key as far as I'm aware, but I haven't.
I mean, you certainly could have author 1, author 2, author 3, but you'd have a finite list of authors for your book. So
I'd have to, yeah, if that's a question, I'd have to get back to someone on if the metadata supports array fields and things like that. Okay, so we've gone through, we've set up our knowledge bases, indexed files into the knowledge base. So the next thing, obviously, is I want to ask it some questions. So we want to go into the querying of the knowledge base. So what I'm going to do first is you'll see here, we want to set up a filter. And I'm going to zoom in because we know, just like everybody else, I can't see. So in here, we're going to set up a filter expression. And this is where we're going to be pulling in the exact same stuff in opposites. So I'm going to, for the lack of being able to type really quickly on the fly. Oh, wrong one. Let's copy the right set of stuff, Steve. That definitely helps. One sec. All right, so when we're doing a query, so up above, this is another Lambda call that is coming in. We from the chat session, right? It called in through the JOT token. I was able to get my tenant ID, my user ID, other information like that. So I've pulled it out up above in this code. And the key thing to look at here, though, is this filter expression. And what it's doing is it's setting up that tenant and the user ID, and then I'm also passing in a list of files. So this could actually be a little bit useful as well later on, is even if they're indexed, you could say, I actually only want to query on 3 of the 100 files that are in there, because to Mike's point, sometimes wikis go out of date or other files go out of date, and if the time hasn't expired, but I know I'm really focused on my search, I could query on that. In this particular example, I just pass in all my file IDs that have been indexed so that I'm searching for my files, and I'm filtering layer after layer to make sure that I'm getting just the stuff that I want to query on.
And it's leaving nothing to chance. So if someone were to inject in the prompt, send me all of the data about tenant 2, that's not going to really help them at all.
So then we have to set up our retrieval parameters. So again, I'm not going to type everything in here because time. So the retrieval parameters are setting up the query, and then we're setting up the model we're going to use for turning our query into the embeddings for the model, and then we're passing in right here our filter expression, and then we can control the number of results as well. So once we do that, now we can go into the retrieve and generate section. I'm going to zoom back out here and go to my to-dos, make sure I got that stuff. Okay, so I think highlighted out some code. I'm just going to put that back in there so it's retrieve params are good. Okay.
And zoom in on that section.
Yeah, I'm going to just leave it as highlighted out code. So what we've done here is we've set up our parameters. Once we've set that up, we would be calling a perform retrieve and generate call. So inside of the knowledge base querying, I'm going to find that file. Hey, where'd it go? Sorry. I'm bouncing around because So from the Bedrock agent runtime, we're going to call the retrieve and generate, and we're passing in those retrieval results. So this is where, again, back to the point of why would you use Bedrock knowledge bases? I set that up as a query for Bedrock knowledge bases. I didn't have to really understand what's going on underneath the hood, what vector store that I'm going to. I'm doing this, I could do this across every single vector store that Bedrock knowledge bases has, and I don't have to change this model at all. So if you wanted to have, if another customer came to you and said, hey, I've got a bespoke use case where I want to use a different type of vector store, maybe there's government regulatory, whatever it is, you don't have to worry about it. You can just spin that up as part of your infrastructure and then just point the code to it, and you should be good to go.
So it gives you a nice, clean separation of concerns on the vector store with the query. As far as the chunking, where is the chunking happening, and where do you configure that?
It's part of the knowledge base configuration. So when we're setting up the knowledge base, we're setting up the data source, and we're going to set up some of the chunking strategies inside of there. But also when we go back to the indexing, set up some of it in here.
I sprung that on him, so
Yeah. When we're setting it up, though, we're setting up individual data sources and data vector stores as a specific chunking strategy and things like that. And then in the query side, we are doing the same thing with the query. So you're setting up the model that you're going to use, the foundational model, and some of the options that you have there. It's not really the chunking there. You're just basically picking the model to be able to do the embeddings. But
any other questions? There we go.
After the question, we go on to the last little bit is just the cleanup part.
I have a question. Maybe it does it automatically, but if a tenant 2, for example, is chatting with their own index of documents or whatsoever, and I update one of those documents, but how does the tenant knows that the document is updated and the embedding is regenerated again, but I don't want to lose the context of the chat, basically. So the document is updated, and the embedding should be regenerated, but the context is lost, right?
If I get your question right, it's like if I'm continuing on a chat and I want to search more and more things, you just have to keep passing the context in of the previous stuff.
Yeah.
So you do start getting a longer and longer context window that happens there. Yeah. And I don't have a good answer for you on seeing if we can slim that down at all. Okay. I think you'll see, like, even in Curo and some of the newer systems out there, they'll hit a limit and then they'll summarize for you and try to push that off to something else. So those are kind of the patterns that have come into play these days until someone smarter than I comes up with a better pattern for that.
Okay. Thanks.
Any other questions?
All right. The last little bit of this is just the cleanup. So we've gone through, again, the stages. We've ingested. We've queried. Now, as we mentioned, we've got a TTL system, right? So whenever the TTL triggers, we've got to go back and make sure, because we're a custom store, there's nothing going on that specifically tells us to clean up all that information. So we've actually got to go in and extract out the file information and everything like that from the TTL trigger. So in the Dynamo database, basically there's a couple things in there. It's the file ID, the data source that it's in, the knowledge base that it's in, and we're going to use that information and we're going to extract it out and delete those records from the knowledge base. And again, in this particular spot, we don't really have to care what knowledge base it is. We're just giving it a command and it figures out what that needs to be and goes off and deletes it. So I'm going to grab that chunk of code here. And it's a rather large chunk of code, so I'm not going to type it in here. Sorry, one second.
So while you're doing that, I mean, when Stephen showed this to me, I thought this was one of the more clever parts of the solution, because that time to live is a really important problem, and you can't just have a single rule for all of your documents. Like, how do you manage that? So, keeping a record of that index in Dynamo, and then using the Dynamo DB stream to essentially trigger that action gives you a lot of flexibility, because you can use the built-in time to live within Dynamo, or you could delete the record manually if there's like a right to forget, or if you're trying to expire a document, like you said, you just delete the record in Dynamo and it will just flow through the whole system.
Yeah, so I was a little off there. It's not a super large chunk of code, but this is definitely, as I mentioned, all I have to keep track of in the Dynamo database is the knowledge bases coming from, the data sources coming from, and the file ID that I want to remove. Technically, I could probably put some extra parameters in here if I want to be very bespoke about like the tenant ID and things like that and make sure we're going through. But for deleting from a knowledge base, really it just needs the file ID from wherever the data source was. So I'm passing in that file ID and then it's going off and deleting it out of whatever knowledge base. So it handles the creating the query and things like that. That said, it's just deleting out of the vector store. It's not deleting out of the storage underlying. So these are separated off systems that we're dealing with too. So I've still got files sitting there in S3 that I could re-ingest later if I really needed to. But I'm just not taking up all the use of those particular knowledge stores, or sorry, vector stores as well. So that kind of ties it up. We've gone through all the stages, we cleaned up the data, and now the users are hopefully happy because they've got a better utilization of their system. Hopefully their costs are going down a little bit. But I would love to hear from everybody too, like what vector stores is everybody else using? Did we kind of peg it with the Postgres, OpenSearch? Has anybody started using S3 Vector yet? So one person out there say, yeah. Has anybody found it useful and good compared to others? Yeah? Okay. I think when the CloudFormation kind of catches up on that, we're hoping that people will start really kicking in and using those things.
Any other vector stores that you're using?
Well, I had more of a question,
Yeah,
basically.
go
We use OpenSearch serverless, and one of the major issues that we're basically having is that in the listing of the documents within the data source, if we use open serverless, what's happening is that the API that we use from our internal services to query the database, that kind of times out if you have like even greater than like 10 documents or something. So is there like a workaround we can use to kind of pre-filter the knowledge base so that, you know, we retrieve the results in, you know, less than 10 seconds or so?
You can hold on to that. I have some follow-up questions for you. What type of metadata do you have on the documents?
So it's basically like file ID mainly. And then, you know, we have the agent ID in there to kind of know, like, this is the file that we need to query, to get the results. And that works perfectly. The major issue that we're having is like when we have the user interface for the customer to see the files that they've ingested into the knowledge base, that's where it times out. Because the pagination is like, it happens very weirdly, like it's super slow. So is there like a workaround that we can use to, when we are, you know, listing the knowledge base documents, is there like a metadata that we can pass to kind of pre-filter the documents so that it's maybe faster?
Yeah, so
it sounds a little bit more like OpenSearch specific type of question.
Exactly, yeah.
I would love to get you set up with an OpenSearch specialist if you haven't talked to one so far.
But see, in your
it
demo,
sounds like though, I mean, if you went behind like a Bedrock knowledge base and you use something like this, then you could maybe get the users to try to track down or have like different sets of files that or documents that they're looking at. I think one thing that we've noticed is knowledge bases can get really big, and the stuff that individual people want to look at is like maybe 10% of the overall. So you could segment it down too by department or by something like that, right? So putting in some of that metadata so you could filter it down that way before you start to do the retrieve and generate might help you out on that.
So a follow-up on that. So let's say, since it's a multi-tenant system, and I think there's like an upper limit or quota for like the number of knowledge bases that we can have in a single account versus the number of data sources. So how we kind of tackle that, I guess. So we run into a bottleneck eventually in terms of scaling, right? That's the main issue, I guess.
and how Stephen addressed that in his demo is he kept that record of files in Dynamo.
Right.
So if you're just listing the files, it's not actually hitting the knowledge base or OpenSearch, just hitting Dynamo instead. And then the tenant ID, you don't have a knowledge base for tenant. You do the segmentation using the metadata on the
yeah, so maybe like I guess moving to a DynamoDB based like file information or something that could help us, I guess.
Yeah, if you're just tracking pure file information stuff, I would say OpenSearch is maybe not. Like OpenSearch is really good at what it does, but if you're just querying out flat-based information, Dynamo is probably going to be a good spot to put it, and it'll alleviate some of the load on your OpenSearch as well, so you don't have to like increase the size of your cluster at all.
All right, thank you so much.
Yep. Good question. I'll be right over.
So in terms of VectorDB, a year ago, before starting using KB, we were using MongoDB, Atlas. Find out that the LLM wasn't very good to do a text to a Mongo query, so we have a few issues. And so since now we're using OpenSearch and not S3 but Postgres, but we still have a footprint on Mongo. And so I'm but we're doing like normal RAG without KB anything. So I'm wondering if we could use KB with Mongo at some point.
We just checked this too. I don't know if Mongo is on the list. I'd have to get back to you. I'm not sure if Mongo is on the Bedrock knowledge base list of vector store or support. So, but if it was, then it would be, yes, you could do that. And it would just generate the queries and everything for you.
I told them they'd stump us.
Yeah, I know. And it's funny, I was just looking over these things like, I know someone's going to ask about that.
We've been interested in using Neptune Analytics just for general like knowledge graph, but also a little bit of vector storage because I think there's that feature within Neptune Analytics. How have you found the integration between knowledge bases with other vector stores? Like, is there a little more customization that needs to be done for Neptune?
I haven't seen too many, like I know like Neptune vectors is, I wouldn't say new, it's been around for a little bit, but yeah, newish. So I haven't personally come across too many that are mixing those together. So, but I mean, when you're setting up the data sources to the knowledge base through Bedrock, it's pretty much the same configuration stuff that you would do for like whatever vector store that you're going to go to. You have a lot of the knobs and dials that you're going to tweak. So I would say if you're tweaking through without it, then you're probably going to be doing the same thing through the knowledge base. You're just saving the switching between the knowledge bases and having to rewrite queries and things like that. It'd be an interesting question to the knowledge base team to see how they're doing the performance enhancing, right? Because they're going to be doing the queries for you into the knowledge store. So it'd be very interesting to see, like, if you're finding that you're having performance issues or anything like that, I'd love to get like that team in front of it and see how they are doing those queries and like what data specifically you're using. So maybe bump into me after this and we can figure that out.
Any others?
All good?
Yeah, I think if there are no more questions, we've solved everything, we've solved every problem, so that's good to hear. Really appreciate you taking the time. Make sure to put the feedback in the app, and I think we're probably between everyone and lunch as well, so letting out a couple minutes early is not the end of the world. So thanks everyone for attending.